Welcome to another Friday. I'll start first with just a quick view at the syllabus, reminding myself how many lectures we're behind here, and show the date again of the first exam. Then we'll go to Lecture 6 and work on the completion of that, and then we'll begin Lecture 7. So I'll switch to the computer and take a quick look at the syllabus. So here we are on Friday, February 4th. We're just working our way to Lecture 7, so obviously we're a bit behind. Typically what happens each semester is, in class anyway, and the ideal situation someday will be for this class, as with the others I'm working for online, all the lectures would be pre-recorded. I don't have one that's exactly there yet. It's a tremendous amount of work. And I always appreciate the patience and understanding of everyone taking the classes as we're piecing it together, so that you'd have every lecture prepared. It's just the slides, not this blah 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 that we typically do for the everyday business in the classroom, and then also to have the classroom to talk about things in slightly different ways rather than the more mechanical presentation of the pre-recorded slides. Any of you that might be in the online physiology course have seen that already, where you've had to jump back and forth between the pre-recorded, piecing it together, so that you'd have every lecture prepared. It's just the slides, not this blah 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 that we typically do for the everyday business in the classroom, and then also to have the classroom to talk about things in slightly different ways rather than the more mechanical presentation of the pre-recorded slides. Any of you that might be in the online physiology course have seen that already, where you've had to jump back and forth between the pre-recorded and the ones from a semester ago, and so on and so forth. So there is a more ideal situation that will come in the future, and I have pretty busy weekends all the time so far, and I haven't had a chance to get any more pre-recorded lectures for this class. I would really hope to be able to get the Lecture 11 recorded and have that available. I won't make the actual promise because it's too easy as an instructor of a class to get trapped in what I ultimately came to call vacuous promises. Promise this and that, and here it's recorded, so you got to kind of live in the face of that. So no vacuous promise, just I hope at least by the time I have to get this Lecture 11 recorded, that my life otherwise will kind of settle down. We'll have a couple of the things I'm organizing more solidified, and have some assistance on things, so that is my aim. So the February 14th, Happy Valentine's Day, will be the first day that Exam 1 will be posted. I believe I've got it up for 4, maybe 5 days, something like that. You have 2 attempts. I want to take just a moment to remind people of the policy for the exams. You are on your scholastic honorship vow with these. I describe academic dishonesty in the syllabus farther down. I won't scroll to it. Basically, you're not allowed to use any materials to assist you in taking the exam, but you get 2 attempts at it. So I use it as a learning tool in the sense that it is also a performance assessment tool, and I'm assessing more so your honest performance of getting to take the same exam 2 times. Study for it, prepare for it, take it once, you see your grade immediately afterward. You do have permission to have a piece of paper and a pencil beside you when you're taking it to make a few notations on some of the questions. Keep in mind that it's timed, so that creates a challenge on your time management performance assessment characteristics in this setting as well. And there's always a time period. I usually have it 1 or 2 hours before you can go and take your second attempt. So don't leave your 2 attempts to the last few hours on the last day that it's available. Do 1 attempt well before and study again and go back to it the second time. The highest score, and it may not be this way forever, but it's kind of nice, I know, especially on your part. Your highest score is the one that counts toward your grade. So I think it's really a reasonable strategy for this approach of taking exams online. I'm comfortable with it. It doesn't mean that every other professor at the university that ends up with a course like this would administer the performance assessment tools in the same fashion. But this is my choice. Primarily, I'm asking quite a bit from the students that take these courses every semester, and I think this is a reasonable model to assess your abilities to do well under these conditions. And I haven't received any complaints yet, oddly enough, right? So I think everyone's pretty comfortable with that. So obviously you can't share the information with somebody else. It's always an insane thing that we tend to do. If you've already taken it and somebody's asking you about it, don't tell them about it. They have 2 chances to. Let them do it on their own. Any process of getting that information through whatever computer technology is obviously cheating. So that's your ethical standard that you have to establish and live with. Also remember that if you become aware of someone that is in that area of to whatever degree of academic dishonesty, basically, if you entered this university as a freshman, I'm not sure how they deal with transfer students, but you take and sign an oath, an honor code oath. So you're supposed to share that information such that it can be investigated more thoroughly, and all the guidelines and regulations for this are, of course, posted on the the UTSA website and in the printed bulletin. So I know it's virtually impossible to police this kind of stuff, but we have to realize that all the same rules and regulations apply. Well, let's shift over to the lecture then. Enough of that blah blah kind of rules and regulations stuff. Week 1, we get to blast assist and implantation. At implantation, we recall that the process is continuous. The inner cell mass will become the embryo. The trophoblast cells will produce the extraembryonic structures. We were kind of following both of those up to this point. Let's shift our attention to the inner cell mass and talk about getting into week 2. So week 2 is days basically 7, or I guess 8 through 14, right? I always mess that stuff up, so keep an eye on me, keep an ear on me, and offer correction whenever you feel it's necessary. So somewhere day 7 and day 8, 9, whatever it is through there's going to be increase in size of the blastocyst and rearrangements of the cells within the inner cell mass. And we will always keep this term in mind, differentiates. What's happening here is the cells are moving farther and farther away from totipotency to pluripotency. So totipotency means you can become anything and everything. Pluripotency means that it's a little more limited. We already said that it's very unlikely that you could take a blastomere from the inner cell mass and have it back up or start there and produce the trophoblast cells and the inner cell mass cells as you would be able to with the 2, 3, 4, 6, 8, whatever cell stages. Was that multiples of 2? I guess not. Or doubling. Anyway. So the 2 layers are those on the lower part, facing away from the embryonic pole, where the syncytiotrophoblastic cells have begun to infiltrate into the endometrium, the hypoblast cells. So they are under the ones that actually are toward that embryonic pole, the epiblast cells. So this is where we are at now. By day 7 or so, there's the complete implantation with the re-establishment of the surface epithelium lining the endometrial surface, and the uterine cavity. So it is possible to see this at different stages with the appropriate technology, where that opening that the blastocyst is passing through is gradually disappearing, and there's ultimately a point at which it is completely covered over. And God continue to give strength and dedication to these people that'll, first the ones that'll volunteer to have the probes placed within the uterine cavity, and those that are willing to spend the time to hunt around and find it. Of course, they'll know basically the typical locations to go and look, and it's obviously not a routine obstetric nor gynecological procedure for people, women that are pregnant. So there's a continuous growth of the syncytiotrophoblastic cells, and we'll see a cytotrophoblastic layer that will begin to appear. And I know these are very small, and this is the approach we take. The maternal blood is approached now, and the events that we talked about will begin to occur. And there's a cavity forming on the what will become the dorsal or the back side of the embryo. So we now can say toward that original embryonic pole is the dorsal aspect of the developing embryonic disc. It's not an embryo yet. It's a two-cell layered disc. And then ventral is going to be obviously the completely opposite pole of that, called the, in some other species, the vegetative pole, because that's where the yolk sac will begin to form. And we see the primary yolk sac even showing up there, so we can even use the vegetative pole. So there's a new chamber, a couple of new chambers that are going to be forming throughout this process as well. So this means at the fringe, I always use this purse string idea, although it doesn't really close down, but it is a purse string that doesn't create a puckering either, but it's that type of a thing. It's a point of constriction where there's no expansion. So as there's cellular growth on a flat surface, there's no place for it to go but to be displaced and then create a balloon on the top and a balloon on the bottom. So this is what's happening as these intercell mast cells come to lie on top of each other, forming really distinct layers, epiblast and hypoblast, and then as they divide, there's going to be a displacement peripherally. Remember, these are three-dimensional. We're always kind of seeing them two-dimensional. So there's this growth of the cells around the side, and they're going to form a chamber dorsally and ventrally with continuing processes. At the moment, we're focusing on the cellular changes, and we'll see this lower panel at a higher magnification in this slide and follow through with the destination, well, not really destination, but terminal differentiation ultimately, no, not even ultimately, sorry, at an intermediate stage within the embryo. So it'll begin to introduce the terminology that we'll see as we begin to follow through the development of the embryo. So 2 weeks, 2 cell layers, 3 weeks, 3 cell layers, 3 cell layers, we call it an embryo. Can't fit in there, I'll wait. So first, the lighter blue cells on the dorsal aspect of this pre-embryonic disc, I'll call it that because it really isn't embryo yet. And you notice that they are displayed as tall columnar cells in the blue with the nucleus in the center. And then on the ventral aspect of this pre-embryonic disc, my own terminology again, we see the yellow-colored cells are still, well, they're made low columnar cuboidal cells, tall cuboidal, low columnar. What's the difference? You got a 5-story building, you can call it whatever you want. But they're at the front end, so toward the nose, toward the head, the cephalot end of this pre-embryo. So cephalon means brain, so cephalic means the head, basically. Cephalad, AD at the end, means toward the head region, that pole of the embryo. So we notice that the hypoblast cells have a very characteristic appearance there. They're very tall. This is very important. There's intercellular communication through extracellular molecules, most likely, definitely cellular contact. Whether or not they give up their tight junctions and allow other cells to separate them becomes very important, especially at this most cephalad portion, as we will see. We already see the indication of these marginal cells dividing and producing a displacement of cells around the edge. So away, the periphery, moving away from the site of origin. So the epiblast cells will continue to differentiate into the ectodermal layer of the amnion, the embryonic ectoderm, and the primitive streak that we'll see a bit later. So these are very important cells. We will follow the embryonic ectoderm into its ultimate target, terminally differentiated cell populations and tissues and organs and so on and so forth. And the ectoderm of the amnion indicates already, we've all heard the term amniotic sac. Oh, my water broke. Well, that's the amniotic sac. So these cells up here, the light blue ones coming from the epiblasts, are going to form that amniotic cavity. So the amniotic cavity originally is on the dorsal aspect of the preembryo and embryo. The primitive streak will contribute many different cells to the embryo and its related structures, obviously. Extraembryonic mesoderm, embryonic mesoderm, a structure called the notochordal process, key to the differentiation of the nervous system, as we will see, ends up becoming the nucleus pulposus within the intervertebral discs. Obviously, we revisit all of this information again, as I had stated last time. And it also will contribute to the embryonic endoderm. The hypoblast cells will contribute to the endoderm of the yolk sac. So we can see already that this two-cell layer obviously becomes 3 cell layers: ectoderm, mesoderm, meso in the middle, and endoderm on the inside. So the dorsal aspect is considered the outside, so it's the ectoderm, the outside portion. In the middle, when we see it appear from the primitive streak, we'll see the intraembryonic or just embryonic endoderm, and already we see the hypoblast contributing to the formation of the yolk sac, and ultimately that will contribute to extraembryonic mesoderm as well. So you see the nightmare of lineage of these differentiating cell lines already beginning to appear. So we've already left behind basically totipotency. Now you can also find applications of this term totipotent simply to being able to produce an entire embryo. So the inner cell mass sometimes is referred to as having that totipotency, strictly for producing everything you need to have an embryo or fetus, but not the extraembryonic structures. So again, you need the host or donor blastocyst to accomplish that type of a thing. But we know in our mind that they're really just pluripotent at this point, certainly very diverse capabilities, but becoming more and more limited in what they can become as they move on down the line. At present, and I don't study this literature really very much at all, at present I'm not aware of any discoveries that allow dedifferentiation back to a spot and then redifferentiation down another lineage. I know there's ongoing work with that, and of course, don't tell anybody if you figure it out. Patent it first. The next topic is the formation of the extraembryonic structures. relevant to this. We've reflected on it as we followed the blue and the yellow cells, the epiblast and hypoblast. So that amniotic cavity will be the space that is within the amniotic lining, that the sac that we have now imagined in our mind developing. So the amniotic sac does not completely surround the amniotic cavity. Why? So you have to picture a little disc that has a balloon on one side and a balloon on the other side, right? So for each of those balloons, dorsally the amniotic sac and the yolk sac ventrally, at one point, that little disc you have separating those two balloons is going to form the lining, part of the lining, right? But the vast majority of the lining of the cavity, the amniotic cavity, will obviously be the amniotic sac developing from the epiblast cells. Now that will change as it goes on. We know that the amnion is not a completely cellular structure, especially at the time that the water breaks and it ruptures. It's going to have some connective tissue in it. So there's probably going to be some mesenchyme get in there, because mesenchyme will end up differentiating into cells that can secrete and maintain the extracellular matrix compartment. The amnion or sac is that layer of cells, and the primary yolk sac is the one that we had seen very close up in the previous slide, being produced from the hypoblast cells, and it is contained within the original blastocyst cavity, or the blastocele. So we had our two balloons inside the original balloon now, so we're a pretty tricky clown. And all these things are going to get their names as we go along. So this slide, we've seen parts of it before. It's just showing us that entire process. The two-cell layer with the exocelomic cavity being identified here ventrally, and the amniotic cavity already being identified dorsally. And then the primary yolk sac will be developing within this original container. And we see that the space between the original container and the two new balloons is real, and will have some contents, right? So none of these are air-filled balloons. In reality, there is fluid contained within all of them, extracellular fluid always present. So what we have to keep in mind is that this doesn't float free. There has to be some type of attachment, and there will be structures developing in the original blastocele that help to suspend it within that original fluid-filled cavity. So these events occur simultaneously with all of the others. So on the right side here, we see in panel A that there's two slightly different appearances of this structure infiltrating the endometrial lining, and ultimately we'll see that there's a cytotrophoblastic layer added to the syncytiotrophoblastic cell layer. So it becomes two different cell populations that are invading with reference to this other extraembryonic structure. All these events are occurring simultaneously. So we can switch our attention to that now. The primordium of the placenta, basically what we just illustrated, those two slightly different shades of red outside of the structure that we had identified all the balloons, and it is continuing to differentiate and grow and develop. So initially, those syncytotrophoblast cells are infiltrating and are the first insurgents, if we want to think of it that way, to encounter the maternal vasculature. So it's the first line of insurgents, if you will, to infiltrate, and they will, as we had noted before, interact with the maternal capillaries and probably just loosen up the connection between the cells and cause the creation of the maternal pools of blood called lacuna. So I don't think it really ruptures the endometrial vessels. It comes upon them and kind of sends out signals saying, you know, let go of your tight junctions, loosen up that connective tissue, we'll kick in a few enzymes and soften it up, and then just gradually there will be an opening of this structure. Just doesn't, you know, rupture it and cause a hemorrhage. It stimulates an interaction between all of these cells so that it creates a pool of blood where the arterial blood moves in and the venous blood comes out. So it just basically becomes one big giant lake rather than an intricate capillary bed. But it's still going to have cells lining it. You're not going to have leakage into the general stroma of the endometrium. It's not a hemorrhage. It's a highly structured arrangement with cellular containment around the periphery of this vascular pool. The extraembryonic coelom, the fluid-filled cavity that I pointed out on that teeny tiny image in the previous slide, the trophoblast cells that surround the yolk sac, the embryonic disc, I still call it preembryonic, and the amniotic cavity, or the cavity of the chorion as it's also called. So we used that analogy of a balloon with two balloons in it, the two balloons joined at that point of constriction where there's a disc in between them. So we're keeping all of these three-dimensional spaces in mind as we create these descriptions. So the extraembryonic coelom basically was that blastocele. I'm not going to try to spend more time on the teeny tiny slides so that we can progress to lecture 7. Then, as we said, we don't simply have any strength to a single cell layered structure that is going to help suspend and protect the developing pre-embryo and embryo and ultimately fetus. So we've got to get some other cells in there to contribute something to toughen up these layers. So we have to have mesodermal cells. Mesodermal cells form that extracellular matrix of fibers and glycoproteins and many other molecules that help stick it all together and toughen it up so that it is resilient and truly supportive, but not constrictive. So the cells from the yolk sac endoderm will give rise to loosely arranged connective tissue cells and divides into two layers. So in our mind, we're seeing that all these cells are being produced, and we're getting plate-like movement of all of these cells. It's not always just from one point of origin and spreading away. They sustain some mitotic activity as they're spreading away, and they're dividing and then producing a second layer, and that second layer, as well as the layer of origin, can go on to differentiate in two different directions. The splanchnic will be the one on the outer surface of this ventral smaller balloon that we had talked about. So it is the splanchnic layer that surrounds the yolk sac, and then the somatic layer lines the trophoblasts and covers the amnion. So by that description, we have to envision cells going on to line the inner portion of the, or I guess the periphery, let me say, the periphery of the extraembryonic coelom. Well, this gives us a feeling for what's happening inside this container. Now let's think about the outside of the container, where the progressive event, they're going to undergo transitions and changes in structure and improvement in performance of their function as they grow toward mature chorionic villi. So these are finger-like projections of the cytotrophoblast that are pushing into the syncytiotrophoblasts. Syncytiotrophoblasts. So we have to imagine a thick layer of foam that can stretch and conform, and then you take your finger and you push up into it in different areas. And if you looked on the other surface, you would see your fingers pushing up, but the foam would be on the top of your finger, and your finger is obviously inside and surrounded by that piece of foam. And of course, on the other side of the foam, you're pushing your fingers in from this side. On the other side, it would be some type of styrofoam balls or something, and all the vasculature representing the functional layer of the endometrium. So by pushing up into there, we are creating the finger-like projections into the endometrial parenchymal cells, including the vasculature on the opposing side. So obviously the primary chorionic villi are two-layered structures made up of several cells in each of the two layers. So that obviously is not an optimal situation to have gases dissolved from the maternal lake, blood lakes, through into what will become the developing extraembryonic vasculature. So we're still at a small enough size that simple diffusion is working all right. But it's not so great with the maternal vascular barrier there, so we create the maternal lakes first. So now the surface of the syncytiotrophoblastic cells are being bathed in maternal blood, so we have a reduced permeability barrier for the simple diffusion. Next, we need to have an embryo side, still extraembryonic in the placenta, circulatory system to begin to pick it up and move it to the over the greater distance and to the larger structures, embryonic and extraembryonic, developing within this concepsus. So there's this progression of improving the capability for simple diffusion and adding a circulatory system on the embryonic side. So ultimately we know the best thing, just like with our lungs, is to get down to 2-cell layer thick membrane. One on as for the lungs, one on the side of the air and the other on the side of the vasculature. Here we're going to have a cell layer on the side of the maternal blood and a cell layer on the side of the embryonic circulation, even though it's extraembryonic initially. So the chorion will be the term used for the layered structure comprised of the extraembryonic somatic mesoderm, the cytotrophoblast, the syncytiotrophoblast, the villi, and the maternal lacunae, and of course it is in a later stage, of course, precursor to the placenta. So the term chorion is inclusive of the chorionic villi, obviously, that are developing as part of it, but it takes into account many other layers, collective layers, with that one term. Then this illustration is showing us some of the detail of this discussion that we've just had. So now we see, obviously, from this lower panel, panel B, the pre-embryo, I'm still referring to it that because it's 2 cell layer thick, is now suspended within a larger cavity, now called the chorionic cavity, because we've established the layers that we just included in the definition of chorion, highlighted here. And that lets us know that we have a much larger structure, a greater demand on metabolism for nutrients, and of course more waste. So simple diffusion is becoming less and less efficient to sustain the rapid growth and development of this entire structure. You know, it's not just the hypoblasts and the epiblast, it's all of these cells at once and continually are placing tremendous demand on the nutrient supply and the ability to wash away the wastes. So the maternal lakes have already begun to develop, and we see that those actually become surrounded by the syncytiotrophoblastic layer, and the primary chorionic villus, the cytotrophoblasts, are beginning to infiltrate into that area. So we see the maternal capillary beds have been opened, but the containment of these is intact. We also see maternal glands opening and uterine glands and contributions from that as well. So the primary chorionic villus is going to begin to develop. So if we were able to find one that has developed sufficiently to do a cross section, so right through your finger surrounded by the foam, we would see there's a solid core of cytotrophoblastic cells, and it's surrounded with the syncytiotrophoblastic cells. And of course, at those points, there would be the interface with the maternal blood, the blood lake. So we'll see a change in this solid core. Ultimately, our finger is going to become hollow, and at the points of the interface with the maternal blood, the foam is going to become extremely thinned around the outside of our finger, and then there will be infiltrating cells in the center of our finger to develop into the placental circulation. Such that at the end of week 2, there's a cluster of rostral hypoblastic cells that become columnar. We saw those already. And at that point of change in morphology, the term pre- or prochordal plate is going to be applied to that site. So the creation of polarity in this pre-embryo is extremely important. What's toward the front, what's toward the back, let's say what's toward the head and what's toward the tail, what's toward the back side and what's toward the belly side. So rostral or cephalad and caudal, caudal toward the tail, and what's dorsal and what's ventral. So we want to establish these 4 poles. If we don't develop symmetrically around these 4 poles, then we won't look very human, I guess, right? So this has to be established. So we'll see that this prechordal or prochordal plate is very important. That's the rostral portion. The epiblasts above that, these hypoblast cells, and these hypoblast cells that are forming the prochordal plate, they're going to stick together. They're buddies throughout life, if you want to think of it that way, and they stick together basically to help prevent developing structures from escaping the pre-embryonic disc and exceeding where they're supposed to be. So our brain doesn't develop and extend out in front of our nose. In a sense, you can think of it that way. So it actually is the future site of the oral cavity. So initially it's going to be positioned like this, dorsal and ventral, dorsal up here, ventral down here. there's going to be a folding in the embryo, and I can't even twist my hands the way that it would have to be. It's going to come around and then be positioned way back here, and then eventually come up and become the part of the oral cavity. So we know that we're working with a structure that's constricted, where these two balloons attach, the amniotic sac and the yolk sac. It's constricted. It can't extend beyond that. And therefore, if when the embryo begins to grow in all directions, and it's no longer sending cells to migrate onto the amnion or the yolk sac, there's nothing for it to do but fold upon itself, curl and contort, and all these different folds are going to occur later to create spaces, structures, cavities, all kinds of things like that. So we need to begin to envision all of that happening so that we understand why we're focusing so much on these key locations, these sites on the map that are, in a sense, placeholders. Many things are going to become placeholders that, and very likely there's intercellular and chemical communication to inform migrating and invading cells that, no, this is this place. You stop. If you're supposed to be here, then this is, go on to do what you're supposed to do. If you're not supposed to be here, what are you doing here? And maybe even tell them to just go ahead and die and get themselves removed. Thus, this leads us to an illustration of all of these structures. We see the extraembryonic structures, the two cell populations that we've talked about. So the syncytiotrophoblasts, I know I'm not pronouncing this right, syncytiotrophoblasts, and the cytotrophoblastic cell layers are the two that we discussed at the outermost periphery of the concepsus. Let's use that term. The amniotic cavity is formed dorsally with orientation toward the embryonic pole to the the epiblast cells that will become ectoderm and contribute also through the to the mesoderm, as we had stated. And then immediately subjacent to that, not quite as tall cells, the hypoblast cells that are going to contribute to the formation of the yolk sac. And we can see the lining of the the primitive yolk sac here, the exocelomic cavity, and then there is a developing matrix of materials in the outer portion of that. The exocelomic membrane is the term for the structure separating that primitive yolk sac from that original cavity. So we have about 5 minutes, so let's get started on lecture 7. So at the end of week 2, we have encroached upon the maternal circulation. We have moved toward maximizing the situation for enhanced and moving toward optimal diffusion. We are sending cells, the first wave and second wave of insurgency cells, to borrow that terminology from the military, I guess, the syncytiotrophoblasts and the cytotrophoblasts to begin to establish the primary chorionic villi. And at the pre-embryo, we have the two-cell layer form the amniotic cavity and sac, the primitive yolk sac with its cellular lining, creating an arrangement with the original blastocele, and are continuing to grow in size and with demand on nutrients and the gases and producing metabolism. So we're pushing as we go into the third week, we're pushing for the establishment of an improved circulation to move the waste to the interface with the maternal blood, improve that interface, the efficiency of that interface with the maternal blood, and of course to absorb and deliver to the developing embryo and extraembryonic structures the nutrients and oxygen. So as we go into week 3, we're going to have continued discussion of embryonic and extraembryonic structures. Week 3, 3-layer. So we end up with a trilaminar germ disc. This is another term for the embryo. So up until we have this trilaminar germ disc, I apply the term pre-embryo, and now we apply the term embryo. The reason we use the term trilaminar germ disc is because we have the 3 cell layers, ectoderm, mesoderm, endoderm, as we know already, that are the germ cells, another term for stem cell, right? Just pluripotent, not quite so totipotent, so we call it a germ cell. And the germ cells are going to be the cells of origin of different cellular, tissue, and organ structures within the organism. So 2 to 3 layers, and the prechordal or prochordal plate is still localized toward the region of the specialized endodermal cells. And this is the condition that morphologically would tell somebody viewing it that gastrulation is going to begin anytime soon. So gastrulation makes us think of stomach, makes us think of gastrointestinal system. So the first sign of a gastrointestinal system is the yolk sac. More specifically, secondary yolk sac, but we'll leave that for the description as we go. So the first evidence, of organ system development is this gastrulation. But let's watch closely and see if the circulatory system doesn't accompany it, does or does not accompany it, at least in the extraembryonic structures. So we went from 2-cell to 4-cell to 8-cell to ultimately 16, 32, 68, and so on and so forth. 64, was it? Cell stages till it looks like a mulberry, the morula, the blastocyst, and we still have the zona pellucida surrounding it, the more well-developed blastocyst. And we've gone through the discussion of the inner cell mass going to the 2-cell layer and 3-cell layer, and that was occurring during week 2. So we see the progression in this upper panel. Everything's getting bigger, more cells, covering a greater overall dimension. Again, this is just a 2-dimensional view through our. We've now gone from a bunch of golf balls inside a basketball to 2 balloons constricted at a disc inside another balloon, and it's continuing to proceed and progress into more and more sophisticated structure. So we've invaded the maternal blood flow, and we see those lakes forming, the primary chorionic villi here, and it's transitioned from relatively well-established primary chorionic villi to well-established primary chorionic villi. The 3rd cell layer is showing up. We're in week 2, so at about day 16 of the embryo, we have pretty good primary chorionic villi. They'll begin to differentiate into secondary chorionic villi. A well-established chorion, and the amniotic and yolk sac are present. Considering first the further development of these extraembryonic structures, we see that by the 4.5-week embryo, so jumping ahead quite a bit, day 16 is basically the 2nd day of the 3rd week, right? 8 through 14 was week 2, 15 through 21 is week 3. So day 16 is the 2nd day of week 3. So rather quickly, we establish this chorionic interaction with the maternal blood. By 4.5 weeks, we have a very well developed chorionic interrelationship between the maternal pools. All of our finger-like projections are going to be thinned down 2 cell layers thick with an embryonic or placental vascular structure. Obviously, we got to get down from an arteriole to a capillary bed to a venule, same old thing any place you go. And on the outside will be the maternal blood bathing that structure. So we have to proceed to that over the next couple of weeks or week and a half or so, such that when the embryo is well established, and we can even see obviously a head region, some limb buds, a tail, the hind limb and forelimb buds, some kind of organs in there, looks almost like the umbilical cord is established. So in the next, not for us in class, we'll do it in a couple of days I think, but for the embryo, in the next couple of weeks, week 3, week 4, and then into week 5, we've got a lot of work to do to set up the circulatory system. We see the yolk sac is already extended well outside, so there's a lot that's going to occur in this gastrulation, and we'll pick up with that on Monday. Thank you for your time and attention, and I hope you have a good weekend. Make sure you get to watch the Super Bowl from the beginning. I think it's going to end quick.